In this video, we're going to talk about angles and just the introduction to a bunch of different varieties of angles you're going to see throughout the year this year in geometry. The first one is we have an angle is a figure formed by two rays with the same endpoint. The common endpoint is the vertex of the angle, and the rays are the sides that make up our angle. So if we were looking at this angle right here, QP is a ray and QR is a ray, and the vertex, the endpoint that they share in common is the vertex Q, and these sides are the rays that make up that angle. So in example one, when an angle is named with three letters, the middle letter is going to be the vertex. So looking at that same angle off to the right, when we have three letters, so blank, 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 the middle letter would have to be the vertex, and that's our Q. The other two letters then would be the other two points that our ray will go through. So we could put a P, and then we could put an R. And that R and the P could be rotated. It could be angle PQR, or it could be angle RQP. So remember, the sides of the angles, or the angle, are two rays with a common endpoint. The sides of the angle shown are QP, and it's a ray, so it starts at point Q and then goes through point P. And the other ray would be QR, where it starts at point Q and goes through point R. And the common endpoint is our point Q. Remember that common endpoint is our vertex as well in our angle. So in example 2, if we label the vertex of the angle shown here on the right, we could put it as point K. Now remember, there are different ways that we can write the names of the angles, so we are going to write 4 possible names. And we could write angle 1, because if you notice there is a angle 1 right here, so it's a little quicker way of writing it. Another way you could name that is just by angle K. So because the vertex is only one letter and there's not any confusion of what angle it could possibly be, we could also label that as angle K. Then if I wanted to use 3 different letters, I would need to use K in the middle because that is the vertex. And if I write JL, that is another way I could write it. And now for this last one, I want you to fill it in and see if you could do that one yourself. You should have realized that we need to write one with 3 letters, and the K would have to be in the middle. L could go first, and then J could go last. So it's just a repeat of this last one, but the letters first and last are switched around. All right, now we have adjacent angles. So if 2 angles in the same plane that have a common vertex and a common side, but they do not have any common interior points. So in our picture over here on the right, we can see that angle 1 and angle 2 will be the 2 angles that are adjacent. And that is because they share the side in common right here, which we don't have a name for that ray, but they have a common vertex, so this vertex they both share, and they share one of the sides, they are touching each other. So if you think of adjacent, adjacent is something that is right next to you, but in this case they need to be touching as well as just nearby each other. With our chart that we are going to see next, you can see that there are going to be some different classifications and how we're going to group our angles. So one way to classify our angles is by the measures of the degrees that they have. And one way to measure the distance around a circular arc is by using those degrees. This means that a measure of 7 degrees is really 7/360 parts of a circle, because remember we're talking about a full circle all the way around, so the most you could have would be 360 degrees. So with acute angles, we know that our angle is going to be less than 90 degrees, but realize it also has to be positive, so we have to put a minimum on it, and we have to put a maximum, and it needs to be less than 90, and it cannot be equal to 0 or it won't have an angle. So the measure of angle A will be less than 90 degrees, but it will also be greater than 0 degrees. For a right angle, we know that the measure of angle A will have to equal exactly 90 degrees. There's no above or below, it has to be exactly 90 degrees. For obtuse, we know it has to be greater than 90 degrees. So that's going to be on the low end, but it has to be less than 180 degrees because then that makes a straight line. So it's going to be greater than 90 degrees, and less than 180 degrees. I'm just making those darker so you can tell that that's the less than symbol. So for our straight angle means that it's exactly equal to 180 degrees. And this next part you will see on your quiz and on your test, but we just need to make sure you can read your protractor and then just also tell us how many degrees and what the measure of the degree will be, but also classify it with one of these 4 possibilities. So letter A, if we need to find the measure of angle CXA, now remember X is the vertex, which is right here, right there, there we go. And it connects C to X to A. So that would be, all of this would be CXA. So we need to look at the degrees. We can tell that it's less than 90 degrees because 90 degrees is straight up and down. So when you're looking at these two measurements right here, it's either 110 or it is 70. And since we know it has to be less than 90, just by being practical about it, it's going to be the 70 degrees. And one thing you'd probably notice me writing is it's this little M in front of it. So that tells us that we are talking about an actual measurement, not just the angle itself. So it's the measure of angle CXA equals 70 degrees. So make sure you write the full answer right here. Then we need to classify it, and because it is less than 90 and greater than 0, we're going to say that's an acute angle. On to the measure of BXF. So connect your B to X to F, and I'm trying to do them with different colors so it's easier to see. We can see that that is going to be more than 90 degrees because we can see it goes past that. And that means when we're looking at our two measurements here, right here, we have 140. And even if it covers up, you can look at the 130, 150. So halfway between is 140. And we have 40. So we're not using the 40 degrees. This would be the 140 degrees. Since it is 140 degrees, this would make it an obtuse angle. For our last one on this side, we need to find the measure of angle AXF. So A to X to F, and I want you to fill in this one on your own. So the measure of angle AXF is a straight line because it goes all the way over and it makes a straight line. That means that you should write that the measure of angle AXF is equal to 180 degrees and it is a straight angle. For these next couple of questions, we're just going to practice some of the vocab you just saw. And in this example 4, we need to find all the missing angle measures and determine which angles have equal measures. So if you notice over here in our picture, we don't see what all of the numbers are. So this angle right here, we have one here and here. So there's 3 we have to fill in first. And what you want to notice is you have different symbols here. So this shows us that we have 90 degrees. So that means that MJK is 90 degrees altogether, which means that since we already have the 42, we can take 90 minus 42, and that gives us our missing angle, which would be a 48 degrees. Next, another very important symbol you're going to see are these little arcs. Now, you don't see them as the same distance away, but that's just so it doesn't look like one big arc. That shows that you have congruent angles between those two. Remember, congruent angles tells you that they're the exact same size, so this one will also be 48 since the bottom one is also 48. For the very last one, we have our angle KJR is what we are missing. Since we can see this is 90 degrees, but this angle is not exactly a straight angle, so we can't assume that all of this will equal 180 degrees. But all the way around in a circle is equal to 360, and we have everything except the missing angle. So we can take 360 and subtract off the measures of everything all together, which in this case is 278. So if you subtract those, we get 82 degrees, so our missing angle is going to be 82 degrees that are left in that circle. So back to our question, now that we found all the missing angles, we need to determine which angles have equal measures. Remember, equal measures means that they are congruent to each other. And you can see over to the side, we have a 48, a 48, and a 48. So there are 3 of them that have 48 degrees. So what I did is I wrote out the measures of each of those angles. So measure of angle MJL, measure of angle NJP, and measure of angle PJQ are all equal to 48 degrees. But those are not the only ones that are congruent to each other and equal. We have 2 that are 46 degrees, so we're going to write out those 2 measures as well. So then lastly, we need to talk about the adjacent angles. And adjacent angles, remember, are ones that they just share a vertex and they share one side in common. That's why it says that we only need to give at least 2 examples, because really we could pair up all of them. We could say this one is adjacent to this one is adjacent to the next one, this one's adjacent to this one, this one's adjacent to this one, this one's adjacent to this one, and so on all the way around the circle until you cover all of them. And then you'd have many, many pairs. So we only have to list out 2 of the adjacent angles. So I wrote out that we have NJM, that's this angle right here. So really you have 2 choices of which one it could be adjacent with. It could be the one over here on the left or the one on the right. So let's go for the right. So then it would be angle MJL would be adjacent. So let's do another set. If we did QJR down here, I want you then to fill in what could the other side possibly be. So one of them could be PJQ or it could be KJR. So we have a few more vocabulary words we're going to talk about, and that is complementary angles and supplementary angles. They're very similar, but slightly different. So complementary angles means that we have 2 angles that the measures have a sum of 90 degrees. So they add up to equal 90 degrees. So that would mean in our picture over there, angle R and angle A are complementary. This means if I add them together, so 37 plus 53 degrees should equal 90 degrees. Supplementary then, if you look at the picture, looks a little different. The 2 angles will still have a sum of a certain number, but that sum will be 180 degrees instead of 90. One thing you may notice about our picture is that together they actually create a straight angle. And one way we can set up an equation knowing that they are supplementary is the measure of angle 3 plus the measure of angle 4 will equal 180 degrees. So in our example number 5, we need to find the missing angle measures again from our picture and then label at least one complementary and supplementary angle in our picture, but we need the degrees before we can do that. As you can see, we have 90 degrees right here. Sometimes it's nice to see the actual 90 degrees. And what you want to look for are any straight angles, because we know that a straight angle is 180 degrees. And this angle right here is a straight angle. That means that I know that all together will equal 180 degrees. So to find my missing one, BFA, I can take 180 degrees and I can subtract these 2 from 180. So if I take 180 and minus 90, I'm left with 90. 90 minus 50 then gives me a remainder of 40 degrees left over. Another straight angle created would be from B all the way over to E. So this is also equal to 180 degrees. So if we have 40 degrees so far and I subtract that from 180, that means we are left with 140 degrees. The same thing we can do from D all the way over to A is also equal to 180. So that means that this remainder angle will also be 40 degrees. And now we have all of our missing angles. We want to label at least one complementary and one that is supplementary. So one that's complementary, we know complementary is 90 degrees, so that has to be our angle right here. But also realize that CFA on the opposite side, 50 and 40 together, gives you that 90 degrees as well. Then for the supplementary, we know that has to equal 180, and if remember we wrote out there's 3 different angles really that will equal 180 degrees, and you remember you have to use 3 different angles or 3 different letters. So for this green one I could do BFE, for this blue one I could do DFA, for the purple one I could write it as my AFD. But notice with your purple one and the blue one, they are the same letters just mixed around, so it just depends on which side you're looking at. So really we only have 2 different ones you would really write, just either the green one and then the other one could either be the blue or the purple one. Now we are finally on to our vertical angles and our last definition we've got in these notes. So vertical angles is a very common one you're going to see throughout the year. And vertical angles is angles that are non-adjacent, so they're not right next to each other, they do not share everything in common. And they are just formed by 2 intersecting lines. These angles also have the same measure and are called congruent angles. So looking at our picture on the far right, we have a bunch of different angles over there. And our vertical angles have to be non-adjacent. So remember, adjacent means that they share a vertex and a side, so 1 and 2 cannot be vertical angles. It would actually be 1 and 3. And the other set could be angle 2 and angle 4, and they are congruent to each other. So if this is 30 degrees, 4 is also 30 degrees. And then remember, if that one is 30 degrees and this is a straight angle, together these two need to add up to be 180. So this would be 150 that's left over. Same would be true on the other side because they are vertical angles, so they are congruent and they have the same measure. So in example 6, we can see how that's set up. They give us one angle, and we know that 46, the 146 and our 6 are vertical angles, which means that they need to be exactly the same measure. That tells us then that angle 6 also needs to be 146 degrees. When we are looking at then how to figure out what angle 5 will be, I know that these two angles, my 5 and 146, are supplementary angles because they equal 180 degrees when you add them together. Remember, when we say that they are supplementary, we can add them together to equal 180. So I set up an equation that we could use to solve that. If we subtract 146 from both sides, that means that the measure of angle 5 is going to be 34 degrees. Then, since we know that the 34 degrees is in there, we know that 5 and 6, or 5 and 7, or that 34 degrees and the 7 are vertical angles, which means they are congruent. So we could say that the measure of angle 7 will also be the 34 degrees because it is the same as angle 5. Now there are a lot of vocab words in this, but make sure you pay close attention to all the angle names. They're going to show up continuously throughout the school year, and you want to make sure you keep them separate.